Hello, I'm Dominic Beesley. For the past 4 or 5 years, I've been playing around with various different what-if scenarios with old BBC hardware. And sort of the way I got to where I am at the moment was I started developing a what-if scenario of what if a BBC had a 6809 processor instead of 6502. And I developed like a single board computer with a lot of add-on boards. Um, and I developed a MOS and ported BASIC and kind of got that working, and it was quite interesting. It's not much faster than normal BBC. I quite like programming as 6809 instead of 6502, and then I thought, well, actually, it's not that much better. It would be a lot more expensive to produce, and then I sort of went down the rabbit hole of thinking, well, what if instead of developing ARM, which I'm not saying they shouldn't have done, what if Acorn had gone more like the MOS route and developed a chipset to do loads of funky graphics and sound and all that kind of stuff that the Amiga chipset did. And I kind of then got hold of, I think it was a 0-page and a Godil and I can't remember the other CPLD, and I tried poking that into the CPU socket and developing some stuff. And from there, it's grown into, I'm now on a Mark II board of this blitter, and it's got several aspects to it that kind of emulate what an Amiga does, but in a BBC-centric sort of way. So the main board of the computer is still a plain old BBC B or Master or Elk or even an Atom, but then it has some co-processors that, rather than running on the tube, run in the CPU socket, so they can take over the entire system. This allows some really fast graphics that I sort of caught the end of the conversation we were just having before about the poking stuff over the tube and the stuff that Rob C's been doing, which is brilliant. But he's still kind of limited that there's got to be a bit of code sat on the BBC, basically moving the bytes from one place to another. So it's kind of limited by the speed of the 6502 and how fast it can poke stuff to the screen. Whereas the actual graphics memory in the BBC, if you can hit it at 2 megahertz, you can do some really fancy stuff. And then the other aspect was the Amiga sound. I always thought that back in the day, that was like, really was the dog's bollocks of computer sound, I think. And the way it was done is quite clever in that you got 4 notes that you could set at different sample rates, which meant the CPU was doing barely any work to produce some really quite good sounding music. So I started playing about with this, mainly just it's a big FPGA that sits in the CPU socket that pretends to be the CPU. And then I went down another rabbit hole of, well, what if there were different processors? So the Mark I and Mark II boards have sockets that allow you to also have a Z80, a 6809, or a 6808 processor as the main processor. I kind of gave myself some constraints of, I think it should be realistic for the mid to late 80s. That kind of limits some of the stuff you can do. So some of the stuff people have been doing recently, which is really interesting, with the Pi shoved into the tube socket or whatever, it's great, but some of the stuff's really not realistic for the 80s because the Pi is basically running at gigahertz plus speeds. And the first board, I've even started saying, well, it should be through-hole components for the main things other than the CPLD, which is kind of pretending to be a ULA. I kind of relaxed those constraints after a while because the through-hole components are becoming more difficult to source, and 5-volt stuff is becoming difficult. So in the end, I kind of relaxed the rules a bit, and I allowed myself 3-volt parts and lots of surface mount. But I still aim that the ideas are stuff that would have been possible in the mid-80s, even if they'd probably been quite expensive or stupidly out of the scope of somebody like Acorn. So, all right, so I just want to share the screen. I don't know how to share screen. Right, can everybody see a PowerPoint
Yes.
slide. Cool. So this is where I've kind of got to these days, which is there's a BBC Micro over there on the right of the screen, and that can be. I've tried this. It kind of works in an Electron. It works. It worked more or less first time in the Electron. There were physical issues, which I'll talk about later. In the Master, I had to make a little interface board because I'd not thought through voltage levels, and the Master's all on CMOS, so it got quite upset by some of the voltage conversion wasn't quite beefy enough for the Master. So there's a little interface board that goes in the plug, but I needed an interface board anyway because the Master, the CPU's the other way around, so to fit it inside the box, I needed a 90-degree turn anyway. And I've also tried it briefly in the Atom, and I kind of got something working in the Atom, but I've not pursued that to any great level. But the stuff towards the left is more the meat of what we're going to look at today. So today I'll probably stick with the stuff that's in the middle. So this is the stuff that's in the FPGA, which is kind of doing the things that an Amiga chipset does. So I think you can see there's DMAC at the top, which is like a DMA controller, which is just a way of transferring memory really quickly. So it has, in things like the Amiga and various other systems, you have direct memory access, which allows the DMA controller sort of sets the address of something, and then the hardware pokes the memory directly into memory. So you can transfer data really quickly. This one can't quite do that on the BBC because it's not set up for it, but what it does is it acts as a co-processor that's just really set up for doing fast copies. So what it does is it takes over from the CPU, and it just does data transfers at flat out speed. Then there's the blitter. That is for moving graphics about it really quite quickly. So I don't know if any people sort of know the Amiga, but one of the big parts of what makes it what it is its ability to move graphics about quickly. This processor is not actually that quick, but it seems quite quick when you're playing games because it's got this blitter coprocessor which is really good at moving graphics about. The BBC presents some challenges there because of the way that the display memory is laid out. It's really a character-based display with bitmap graphics overlaid on it. So the blitter has to do quite a bit of jumping through hoops to work out where it is when it wants to draw the next dot. The next part is the sound chip, which, like I say, it's almost an identical copy of what the Amiga does. There's a memory controller that's basically, at the moment, it doesn't do a lot other than provide sideways RAM access to the chip RAM and the flash ROM. There's bus control, which is just like logic for arbitrating between the system and memory buses. And there's a thing called the Aeris, which is Latin for copper. And if anybody's familiar with the Amiga, it had a coprocessor that did really fancy raster graphics stuff. So it's like some of the demos that have been coming out recently where people are chasing the raster and doing stuff at specific instance in time to keep up with the beam drawing the graphics. This makes it a lot easier. It's just basically a really simple CPU that is timed to follow the beam as it goes along the tracing out the graphics. So you can set, I'm going to wait until I'm on line 25, position 6 across the screen, and then I'm going to poke one of the palette registers. Sorry, as usual, my phone's just started ringing. I'll just have to turn that off. Sorry about that. And then at the far left of the screen, there's some RAM and ROM. Now, again, the RAM's kind of breaking it's got to be realistic for the 80s. You probably wouldn't have been able to afford 2 megabytes RAM, but you don't have to use it all. We can pretend. And then the flash ROM is quite big as well. The reason I did a big flash ROM was that you can switch between a 6502 processor and one of the other processors, and it's quite handy to have a different set of ROMs for the two. So there's space there to have a full set of ROMs for both processors and just flick a switch and switch between one and the other. Anyway, that's enough talking. I just want to show you some sort of quick demos of what this actually looks like. So to do that, I'm going to have to try and switch my screen. So I don't know how do I stop sharing? Can people still see the slide, or can you see a BBC Micro?
We can see
a BBC Micro now.
Excellent, good. Right, so the first thing I did was a quick test out of the blitter. So what it does here is it loads a big font into memory and does a scroll text. So I'll just start this going. I'll just talk through it while it's running. I may have problems with the filing system here. I'm using a hostfs over a serial cable, and every now and again it gets its knickers in a knot, but I think it seems to be working now. Here we go. So here's some, it's pretty basic scroll text, but I think this is probably quite difficult to achieve on a raw BBC Micro, or some of the stuff that's been coming out recently has been mind-blowingly good. So can you see that? Is it horribly flickery, or is it easy to see?
It's a bit flickery, I suppose.
It's okay. It's okay.
Is that better?
All right.
It's a bit jumpy.
It's okay.
Zoom doesn't do it justice. This is running at 50 frames a second. So on a CRT, it looks amazingly smooth and nice compared to most stuff. I mean, and I'll just talk you through some of the stuff it's doing. So here it's writing all of the font once every screen, but it's also copying the entire screen from a background buffer onto the screen 50 times a second. So when the blitter or the DMA controller are running flat out, they can copy to the graphics memory at roughly 2 megahertz. So it takes half a 50, a hundredth of a second to copy an entire Mode 2 screen. Of course, the colors are great here as well, because it's using Rob's Neuler to do the palette. So I don't know what else to say about this one. Oh yeah, and the other thing that the blitter does is when you're plotting sprites with it, so each of these, the letters is basically a sprite, and as it plots it, it will save what's underneath it to another buffer. So instead of it just starting with a blank screen each time and writing the text, it's actually writing the text out, copying the background screen to the real screen, and then unplotting all of the text before it replots it again, scrolled along a bit. So in the real world, you probably wouldn't do it like that, but it's just to test out how quickly the hardware could work. So I was quite, this was the first thing I sort of did, and I was quite amazed that, wow, you can actually, with something like this, you could do this. This is with the CPU, I think on this demo is running at 2 megahertz. Some of the other demos, if the program is in the chip RAM, depending on what CPU is running, it can run at 8 megahertz as well, or up to 8 megahertz. So some of the processors we've got there, like the 68008, when it says it's running at 8 megahertz, effectively it's really running at 2 megahertz. It takes 4 or 5 cycles to do one memory fetch. So I think we'll do questions at the end, so I'll not blather on about this anymore, and I'll show you something else. So I can't remember which disk is which. So the next thing I thought I'd have a go at was line drawing. So this is really very much a work in progress. I sort of started this middle of last year, and I've never properly finished it off. This requires me to run as a 6809. Basically, so I just wrote the software for the 6809 because it was easier. So if I'll reboot, and now we are running, now the main processor is a real 6309 processor. So I've ported a few things here. Like I said, I ported BASIC, I ported the MOS, which is basically unfinished, but you can do most things, and a couple of filing systems. So it's got the hostfs filing system ported across as well. What we'll look at here is I did some line drawing code. So the next thing that a lot of the graphics accelerators do is taking over the plot code. So this has got a hacked MOS in it, which instead of using its own plot routines, uses the hardware acceleration of the blitter to do some line plotting. So I'll try and load the right program. So here's a really quick and simple test program, which, see there, that's the MOS drawing lines in its usual, using its usual code. So it takes about 4.5 seconds to draw 20 of those spirals. And if I turn the graphics acceleration on, oh, it's not Star TV, it's Star FX, sorry. Run it again, hopefully it'll go somewhat faster. So it's roughly 3 and a bit times faster. Like I say, this is unfinished, and the main thing I really wanted to get working with that was some triangle plotting, because then we could do some really fancy. I probably need help because I'm not that great a programmer, but porting Elite to actually have solid shapes rather than just lines exclusive to the screen. Like I say, I think this is still realistic for a 1980s computer. The Amiga had stuff like this in it. PC graphics cards were starting to have stuff like this in it, and you know, in the 70s, some of the high-end workstations had these kind of things in it. The next thing, if I can show you, is the music-y stuff. So I'll need to swap back to being a 6502 again and reboot. I'll just be a second. I've got to find the switch. So I'm sure some people have probably seen this already because I've posted up the Polar chip. I've also done a version for Hoglet's 1 megahertz bus CPLD card, and I've posted up BBEM and BM emulators with just the sound card part in it, which both work. So if you want to play with this ProTracker stuff, when finished, those are available somewhere on the forum. So let me just start this up. Now this may sound awful over Zoom. I've not really tried this, so tell me if it's just an awful racket, but I'll just start a tune playing. So I don't know if you can still hear me, or if that's too loud. I might just turn it down a wee bit. I've lost my turning down knob. Could anybody actually hear that, and can you hear me over the top of it?
Yeah, I think you turned it down a bit too much. I think you turn it up a little bit.
Yeah. It's got some huge 1940s speakers on it at the moment, so it sounds very loud here, but I'm sure I'm even louder. So what this is doing, it's an unmodified Amiga ProTracker song that's been played by a tracker player that's written in 6502 assembler, and it can run with, it can do this and it can do other stuff at the same time. So there's a few like little gadgety things on here that don't really do much. But it would be possible to get this playing in the background of a game quite easily. The real constraint on that is how you shuffle the memory about, because the songs on bit themselves are quite large, so they can be up to like a megabyte in size. You need to be able to see about 4K of it at a time to be able to get the pattern into memory, and then the rest of it's just poking hardware counters. And we'll stop this because I can't hear myself think. And like I say, the way that the Amiga sound chip worked, which is different to modern sound cards, is that most modern sound cards, what they do is they will play samples at a fixed rate, say 48 kilohertz, and the CPU has to do a lot of shuffling around and DSP to then, if you want to play different notes, to stretch or compress the samples in time domain before poking them to the hardware card. Whereas the Amiga chip, what it did was add 4 independent channels, and you could load a sample into each channel and then just play it at different rates and set the volume and the sample rate on each channel independently. So for different notes, all you had to do was poke 2 bytes to a hardware register. Whereas if you're doing it with DSP, you have to do hundreds of thousands of calculations a second. So it can, like I say, this is a 6502 program running at 2 megahertz, and it's got CPU cycles to spare doing this. So I was quite impressed by, wow, if we'd had something like this, it would have been. So is that Simon? Is it me you want to show more lists of files? Yeah, Mr. Farty. So yeah, I can't
But
remember.
we're sort of running slightly over time.
Okay. I'll try and get.
Have you got anything else to demo? Because I don't really want to cut you off if you have.
Yeah, no, I have. So I just wanted to show the Aries thing, which is a
Excellent.
chip.
Yes, please.
Okay, I'll just do that. So I'll have to remember which disk it's on. So let's go. So here's something showing the Aries thing running. So I'll just look this up. So as you can see here, what it's doing is it's doing some blitting to get the big writing on the screen and the owls flying past. But then it's halfway along the line, and on different lines, it's changing the palette. So it's poking stuff into the palette registers at the start of the line and in the middle of the line, and again at another position in the middle of the line to get the colours changing in the middle. So you can see the rainbow background. That's just one colour, and the palette's been poked about in the background. Those were the only things I really wanted to demo. I don't know if I've talked for quite a long time as usual. I really wanted to show the boards themselves, but I guess that will do for the demo. Is there anything anybody wanted to see again or ask about?
Yeah, I was just going to ask, is there an editor, a protractor editor? Sorry, you can't see me, but yeah, is it anything like that exist on the BBC?
No, I mean this is the first time you've been able to play protrackers, but
right.
they're just standard protracker files, so you can edit them on an Amiga, or there's a PC program for it.
I wonder if somebody could, if that would be possible.
Well, somebody would need
that'd be quite cool.
One of these cards, and then they'd need the time to do it. It's the editor itself.
Really impressive.
If you look at the editor, the code itself, it's quite an involved piece of code. The editor itself. So you could maybe start with the source code for Protracker 23, which I think is GPL'd and you can get hold of, but it's a big old program.
Yeah, I quite like the idea of being able to edit mods in teletext. That quite appeals. Yeah, but that's really impressive.
That'd be good.
So okay, all right. So this is a board you put in your BBC Micro. Sorry, I came in a bit late. I don't want everyone to, but it's a sort of board you put in your BBC Micro, is it, or something?
Yeah, it just sits in CPU sockets. I'll just I'll
read about it because you've already done your demo.
I don't know if you can
15 minutes.
see my webcam now. This is kind of what the board looks like. So this is the master version, which has got the extra bit on to, if you can see on the back, it rotates the chip around by 90 degrees because the CPU socket is a different way around in the master.
Sorry, can you hold that up again? Because I don't think.
Yeah, sorry, the light's really bad in here, so I had to turn all the lights off to.
Interesting.
So it's quite big, and half of the board is taken up. So down this side, these parts. Actually, if we've got time, I've got somewhere in here. So that's how it started out 5 or 6 years ago. This is a Mark 1 board, and here this is the board as it stands at the moment. So in the big square in the middle is where the FPGA sits, and I used a WaveShare board because they were cheap and cheerful from AliExpress. I bought 10 of those, I think, in case anybody wanted one of these. But you can see there's the sockets for the CPUs. You can run it without any CPU at all because it's got a soft 6502 in the FPGA. That's the plug that plugs into the motherboard. So you can either have the plug on top, which is the way this one is because it's an Electron version. The BBC version, it's got the plug on the bottom and plugs straight on top of the CPU. There's the memory chips. That's where the FPGA sits. And these are like the configuration, and it's also got pins for putting up one of Dave Banks' debugging systems on it.
Wow.
Anybody else got any questions?
The thread for this then, Dominic, is the blitter for the Beeb thread, is it?
That's right, yeah. There's some stuff in a 6809 thread, but most of it's in the blitter thread. So I've posted up a few things recently. I've had a 6-month hiatus. We moved house, and I've just been decorating this workshop that I'm sat in at the moment. But the thing I'm probably going to work on next is getting some master type memory stuff working for the Model B. So like the Hazel stuff on the master, so that you can have page at EOO when you start up, because I think it's one of the most useful things. And then I'm going to start playing about with seeing if I can speed up ADFS hard disk transfers using the DMA controller, and maybe even tube transfers. So one of the things I did a few years ago was porting Linux to Spro's ARM coprocessor. But the thing that really limited it was it took about 15 minutes to start up, because just copying the X megabytes of code across the tube takes a while. But I think with the blitter, you could basically have 1 megabyte per second transfers from a hard disk, which in modern terms isn't very fast, but is a lot faster than the BBC does it. And then a network card that I've been working on as well will be fast. Right, just to say, while I remember as well, I've been working on a version of BM, so people can, if they want, download a copy of that. I'll put that on the thread at some point in the next week.
It's
wow.
definitely splendid stuff. What would the possible future be for people getting these boards? Are you thinking of becoming a manufacturer or not?
I don't know. I mean, when I made the Part 1 board, I made a couple, and I don't think I've ever plugged them in. So I kind of lost heart in making boards due to lack of interest. But I have to say, when the Mark 1 board didn't really do much. Well, it did all the stuff that this one does. But when I sent them out, I probably sent them out a bit prematurely and didn't really explain them properly. I think probably what I'll do is I'll probably develop this a bit further, because most of the work now is software. There's utility ROM that needs to go with it to make it work, and then there's a load of operating system stuff to make it work. And then I think probably the next version of the board, I'll make a cheaper version, which has just got one CPU socket, because a lot of the cost of the board is the real estate for the CPU sockets. And I'm not sure. I don't know the feeling, but I think most people probably don't want to put a 68,000 chip in a CPU socket. If they want to do that, buy an Amiga. Maybe
one of the things you could do is to hard solder small surface mount variations of the CPUs. So there's certainly a quad flat pack version of the 65CO2 available. I'm pretty sure that the Z80 comes in a quad flat pack. I don't know about the 68,000 series or the 6809.
Yeah, I mean, that was a thought. The reason it is the way it is at the moment is that you can only have one hard CPU at a time. So to get multiple CPUs and switch between them would require quite a bit more work. Whereas at the moment, it will work with a CPU and a soft CPU. So you can switch between a 6809 and a 6502 like I just did. But having them all on the same board at the same time would require a lot more switching logic. Whereas at the moment, it's just one socket works at a time, and all the other ones put out random signals on their pins. But what I was thinking is one plug and a daughter board if you wanted the CPUs, and then or maybe nothing else. And there's some expensive stuff on there, like there's CMOS RAM, which probably most people don't need, and the battery-backed memory is possibly overkill. So I could probably cut it to half the size and make it a bit cheaper. But I don't know what the interest would be. I mean, I don't know how many people would want one of these. I think until people have got them, nobody will develop the software, and then until people have developed the software, nobody will want one. So maybe the emulator route first is the way to go.
Well, thank you very much indeed.
Yeah, sorry to have gone over by so much.
No, you're on time actually, exactly 2 o'clock, and it was fascinating. You don't know, but Dave and I were having a chat about your overrunning, and we both came to the conclusion it was too interesting to interrupt you. So thank you very much indeed.
Thank you.